on reviewing fuzzy regression discontinuity designs. My name is Cora Goldston with American Institutes for Research on behalf of the WWC. We'll get started with the webinar in just a moment, but in the meantime, please feel free to introduce yourself in the chat box with your name, your role, and organization, and we'll get started soon. Welcome to everyone who's joining us for today's WWC webinar on reviewing fuzzy regression discontinuity designs. My name is Cora Goldston with American Institutes for Research on behalf of the WWC team, and we'll get started with the webinar in just a moment, but if you're just joining us and haven't already, please go ahead and introduce yourself in the chat box with your name, role, and organization. Thank you for joining us, and we'll get started shortly.
Well, good afternoon, everyone. Thank you for joining us today. My name is Josh Polanin. I am a principal researcher at the American Institutes for Research and project director for the What Works Clearinghouse's Statistics Website in Training, or SWOT contract. On behalf of the WWC and the Institute of Education Sciences, I welcome you to this important webinar. Today we will focus on the topic of the WWC's Standards and Procedures for reviewing evidence from fuzzy regression discontinuity designs, or fuzzy RDDs. The webinar will be led by two experts on fuzzy RDDs and the WWC Standards and Procedures, Dr. Emily Tanner-Smith and Dr. Christina Likowski. Dr. Tanner-Smith is an associate professor and associate dean for research in the College of Education at the University of Oregon. She is an applied research methodologist with experience in meta-analysis and research synthesis for evidence-based decision-making. Dr. Tanner Smith leads our training on RDD and single case design standards and procedures for the SWOT contract. Dr. Lukowski is a principal researcher at the American Institutes for Research. She has an extensive experience conducting RDDs in education and related areas, and is a certified WWC reviewer in Group Design Standards version 4.0. On today's webinar, the presenters will describe the WWC's criteria for reviewing fuzzy RDDs, which were released in the version 4.0 Standards Handbook. In addition, the presenters will provide several examples of fuzzy RDDs and the WWC review criteria applied to those studies. The information presented will be useful in two primary situations. First, the presenters will share information that will be useful to researchers who intend to conduct a fuzzy RDD and have it meet WWC standards. Second, the presenters will share information for WWC certified reviewers who will conduct reviews of these studies. As part of the webinar, the presenters will share links to resources within the chat box. You can also send questions directly to the presenters in that chat box. We have set aside time at the end of the webinar for our presenters to respond to the questions. Before we get started, we wanted to share the goals for this webinar. We hope you leave today with an understanding of fuzzy RDDs in general, how to apply the WWC's evidence standards to fuzzy RDDs, and how instrumental variables are used to estimate intervention impacts in fuzzy regression discontinuity designs. And with that, I'll turn the webinar over to our first presenter, who will start with an overview of fuzzy RDDs. Christina?
Thanks, Josh. Before we jump into the standards around fuzzy regression discontinuity design, I'm going to begin by providing just a very brief overview of what regression discontinuity design is and what we mean when we talk about a fuzzy RDD. And then I'm going to discuss how we talk about, or how we calculate impacts from a fuzzy RDD. A regression discontinuity design is an appropriate and potentially very powerful causal research design, particularly well suited when a program or policy allocates participants to conditions based on how they score relative to a cutoff value on some sort of continuous variable. This variable is commonly referred to as the forcing variable, though you'll sometimes also hear it called the assignment variable or even the running variable. Often in education research, this variable will be a score or a percentile rank. I want to mention also that for this presentation, we'll generally be thinking about participants as individuals, but larger units such as classrooms or schools or districts may also be the unit of assignment. There are two broad categories into which regression discontinuity designs fall. The first is called a sharp RDD. In a sharp RDD, all participants receive their assigned intervention or comparison condition. Meaning, for example, if students below a particular cutoff score are meant to receive an intervention and students above this cutoff are not meant to receive the intervention, then all students scoring below do in fact receive the intervention and none who score above do. Statistically speaking, the probability of receiving the intervention increases from 0 to 1 exactly at the cutoff. The second category of regression discontinuity designs is called a fuzzy RDD, which is what we're going to be discussing for the most part today. In a fuzzy RDD, not all participants receive their assigned condition. Instead, there are what we call non-compliers, and these are individuals who, for whatever reason, do not comply with their treatment assignment. Some individuals who should receive the intervention based on their score may not. These individuals are called by the very technical sounding name of no-shows. And some individuals who should not receive the intervention based on their score may, and we call these individuals crossovers. In a fuzzy RDD, there may be only no-shows, only crossovers, or both, which we'll discuss in greater detail in the coming slides. There must, however, be a jump in the probability of receiving the intervention right at the cutoff, but this increase is less than 1. So one of the greatest things, in my opinion, about regression discontinuity designs is how visually intuitive they are. Here you see a visual representation of a sharp RDD. You can see on the x-axis that we have the forcing variable, and on the y-axis we have the probability of receiving the intervention. On the left-hand side of the cutoff, represented by the dotted line in the middle, the probability of treatment is 0, while on the right side the probability is 1. Conceptually speaking, what this means is that an individual's score on the variable x, that forcing variable, and only this score is determining their receipt of the intervention. Here again, we have the forcing variable on the x and the probability of treatment on the y. However, here we see that although the probability of receiving the intervention jumps from what looks like maybe about 0.25 to about 0.75 at the cutoff, the probability of the intervention receipt is not 0 for all values of the forcing variable below the cutoff, and it's not 1 for all values above. This means that something else, in addition to an individual's score on the forcing variable, is determining their intervention receipt. Again, in this example, we have both no-shows above the cutoff and crossovers below, but it may be the case that there's only one or the other. It's also common to see that the probability of intervention receipt is greater closer to the cutoff on the comparison side and lower closer to the cutoff on the intervention side, as in this example, because these are individuals who are on the margin of receipt. That need not be the case. If the probability were a flat 0.25 below and a flat 0.75 above, this would still be a fuzzy RDD. Here we have another visual depiction of sharp and fuzzy regression discontinuity designs. In this example, pretest is the forcing variable shown on the x-axis, and the cutoff for treatment is 50. Students with scores below 50 are assigned to the intervention, while students with scores above are not. On the y-axis, we have post-test scores, so we have an outcome. You can see on the first graph, the one on the left, that all students with pretest scores below 50 are represented by little blue triangles, showing that they received the intervention, and all students with pretest scores above 50 are represented by red circles, showing that they're in the comparison condition. This is therefore sharp RDD. The dashed line on either side of the cutoff is the regression line on either side, and you can see that there's a difference in average test scores at the cutoff, with students in the intervention group scoring about 5 points higher. On the second graph, the one on the right, we can see that there are some blue triangles to the right of the dotted line and some red circles to the left. This means that there are non-compliers, both no-shows and crossovers. There's still a difference at the dotted line, just demonstrating a positive effect of the intervention. Okay, so due to the non-compliance in fuzzy RDDs, in order to determine the effect size of an intervention, we must calculate the effect of the intervention on participants at the cutoff value who receive the intervention because they were assigned to it. These individuals are called compliers, and the effect is called the complier average causal effect, or CASE. Sometimes, particularly in economics, this is referred to as the local average treatment effect, or the LATE. So in order to understand who we're talking about when we say compliers, I want you to take a look at the rectangular graphics in this slide. On the left, we have the intervention group, and on the right, the comparison group. The first row of individuals are our compliers. These are the folks who, on the left, when they're assigned to the intervention, are in fact treated, T equals 1, and on the right, when they're assigned to the comparison condition, they're not treated, T equals 0. So these are the folks for whom we're calculating the effect. In the middle row, we have what are called always takers. You can see that they are treated by the intervention, T equals 1, regardless of whether they're assigned to the intervention on the left or to the comparison group on the right. Always takers assigned to the comparison group are our crossovers. And in the bottom row, we have the never takers. So these individuals are not treated by the intervention regardless of their assignment. So T equals 0 both on the left and on the right. So the never takers assigned to the intervention group are our no-shows. So one thing I want to mention, because it becomes important in a moment, is that we're not able to distinguish compliers from always takers in the intervention group or compliers from never takers in the comparison group. We're only observing their treatment condition. So we don't know that always takers would have participated in the intervention even if they had been assigned to the comparison group, or that never takers wouldn't have participated in the intervention even if they had been assigned, because they weren't assigned, so we can't observe that. There's one important assumption that must be met in order for the RDD to be valid, and this is called the exclusion restriction. The exclusion restriction stipulates that the only channel through which assignment to conditions can influence outcomes is by affecting take-up of the intervention. For example, if assignment of a student to treatment also causes parents to obtain other services unrelated to the intervention, this is a violation of the exclusion restriction because it might influence the student's outcomes through a channel other than participation in the intervention. It also must be the case that there are no defiers, so that is, the assignment to condition doesn't influence take-up status for any individual in the opposite direction of what they were assigned. And because, as I mentioned on the previous slide, we are unable to distinguish compliers from always takers in the treatment condition or compliers from never takers in the control condition, it must be the case that the outcomes of the always takers and the never takers don't differ between condition assignment. So if a particular student who is an always taker is assigned to the comparison condition but participates in the intervention, their outcomes are the same as if they were assigned to the intervention and participated in it. Okay, so now we're going to move on to discuss how to calculate the complier average causal effect in a regression discontinuity design. In order to do this, we employ an instrumental variables approach, which is called the two-stage least squares. Broadly speaking, an instrumental variable approach allows for the causal effect to be calculated by finding some exogenous variable that's associated with an outcome only through its association with intervention receipt. So in a fuzzy RDD, the side of the cutoff is the instrument. Whether an individual falls just below or just above is only associated with the outcome because it influences the probability that an individual receives the treatment, as we stipulated in the exclusion restriction. The case is calculated as the ratio of two discontinuities at the cutoff. The first is the impact on the outcome at the cutoff. So this is the difference in the outcome between the intervention side of the cutoff and the comparison side of the cutoff. We get this difference by subtracting the outcome on the comparison side from the outcome on the intervention side. The second is the impact on the intervention participation at the cutoff. This is the difference in the percent of individuals receiving the intervention between the intervention side of the cutoff and the comparison side of the cutoff. Again, we get this difference by subtracting the percent of individuals receiving the intervention on the comparison side from the percent of individuals receiving the intervention on the intervention side. Then lastly, we divide the first discontinuity, the impact on the outcome at the cutoff, by the second discontinuity, the impact on the intervention participation at the cutoff. And just to bring this back for a moment to fuzzy versus sharp RDDs, because the difference in intervention participation at the cutoff is 1 in a sharp RDD, right? It goes from 0 up to 1, and that's the denominator in this ratio. The causal effect for a sharp RDD is simply the difference in the outcome at the cutoff, so just the top. Okay, so we've covered a lot in a short amount of time, and we're going to take a moment to pause for 2 knowledge checks using the following example. Since 2002, all grade 3 students in Florida are required to meet the level 2 benchmark or higher on the statewide reading test in order to be promoted to the 4th grade. However, there are a number of what are called good cause exemptions, which allow students to be promoted despite failing to score at the level 2 benchmark or above. For example, scoring above a certain threshold on an alternative test, passing a teacher portfolio, or being designated as an English learner. Researchers have used this natural experiment to examine the effect of 3rd grade retention on later outcomes such as test scores, graduation, and suspensions. Our first knowledge check question: is this a sharp RDD or a fuzzy RDD? So you should have a box that just popped up on your screen. You might want to move that over if you want to be able to read the slides, and then you can vote on your answer. Okay, it looks like about 70% of you have answered. So let's see what you all think. Okay, so 94% of you say that this is a fuzzy RDD. So let's see what the answer is. That is correct. This is a fuzzy RDD. There are exemptions to being retained for students who fail to score at the level 2 benchmark. Therefore, the probability of being retained before the cutoff is not 1, or below the cutoff, I should say, is not 1. Also, there's nothing stipulating that students who score at level 2 or above cannot be retained, so the probability of being retained above the cutoff is likely greater than 0. In short, there's something else other than just the students' test scores that's determining whether or not they're retained. Okay, so thinking about this same policy, consider this second knowledge check question. Students who scored just below the cutoff for retention have an average reading test score of 300 1 year later, while students who scored just above the cutoff have an average reading test score of 288. If 80% of students who scored just below the cutoff are retained and 20% of students above the cutoff are retained, what is the complier average causal effect of being retained on reading test scores 1 year later? And remember that the case is the impact on the outcome at the cutoff divided by the impact on participation at the cutoff. So is the case 12, 15, 20, or 25? We should have a box for you to vote in just a sec. There we go. Okay, so let's see what you all think. So 52% of you say 20. Let's see what the answer is. So that is the correct answer. The answer is 20. So let's go through how we calculate that. First, we need to calculate the impact on the outcome at the cutoff. So this is the difference in later test scores between students just below on the retention side of the cutoff and those just above on the promotion side of the cutoff. So that's 300 minus 288, which is 12. We then calculate the impact on retention of scoring just below the cutoff. So this is the difference in the percentage of students retained at the cutoff, which is 0.8, 80% of students, minus 0.2, 20% of students. So here we have 0.6. Finally, we divide 12 by 0.6, which equals 20. So the average effect of being retained on reading test scores 1 year later for students who scored at the threshold for retention and were retained is 20 points. Now I'm going to turn it over to my colleague, Dr. Tanner Smith, who's going to discuss the WWC standards for reviewing fuzzy RDDs.
Thank you, Dr. LaCalci. So now that we've provided a general overview of fuzzy regression discontinuity designs and the methods that we can use to estimate compiler average causal effects, in the next section of the webinar, we'll now move to discussing the WWC standards for reviewing evidence from fuzzy RDDs. So first, it's important to clarify what types of regression discontinuity designs are eligible for WWC review, regardless of whether those might be sharp or fuzzy RDDs. And a study that uses a regression discontinuity design must meet 4 criteria in order to be eligible for review by the WWC. So the first criterion is that treatment assignments must be based on a numerical forcing variable, where participants on one side of a cutoff value on that forcing variable are assigned to an intervention condition, and the participants on the other side of that cutoff value are assigned to the comparison condition. So in other words, studies that use multiple assignment variables or multiple cutoffs for the same sample would not be currently eligible for WWC review under the regression discontinuity design standards. The second criterion is that the forcing variable must be ordinal and thus have an inherent ordering of values from lowest to highest. And that ordinal forcing variable must have at least 4 unique values both above and below the cutoff value. The third criterion is that the study must not have a confounding factor or some component of the study design that's perfectly aligned with either the intervention or comparison group. And then finally, the forcing variable used to calculate intervention impacts must be the actual forcing variable that was used for assignment to conditions and not a proxy or estimated forcing variable. The WWC considers a variable to be a proxy forcing variable if its correlation with the actual forcing variable is less than 1. So if a regression discontinuity design study meets all 4 of these criteria, then that study is indeed eligible for WWC review using the WWC's RDD standards. So let us pause here for a quick knowledge check on the 4 criteria for whether a study would be considered eligible for WWC review using the WWC's RDD standards. So let's say that the state of North Carolina successfully competed for federal Race to the Top funds to turn around the lowest 5% of the state schools through the Turning Around the Lowest Achieving Schools program, or the TALIS program. Assignment to the TALIS program was based on a school's 2010 composite score, which is calculated as the percentage of reading, math, and science and end-of-course tests passed out of all such tests taken in the given school. So the bottom 5% of schools in each type were placed in the TALIS program, but additional high schools were also placed in the program based on low graduation rates. Overall, 89 of the 1,772 North Carolina public elementary and middle schools were eligible for TALIS in the year 2010. TALIS included a variety of program elements, including mentoring for new teachers, regional leadership academies for principals, and customized support and professional development. Schools were considered TALIS program schools regardless of how many or which elements of the TALIS model they utilized. So the bottom 5% of composite scores was not used for any other non-TALIS programs or supports, and all schools below the cutoff participated in the program, as did 2 schools that scored above the cutoff value. So let's say a study used a regression discontinuity design to examine the effects of TALIS program participation on students' later math and reading test scores. Let's say that the authors had access to the school composite scores that were used to determine eligibility for the TALIS program. So now we'll again use the Zoom polling feature, and I'd like you to answer either yes or no to the following question. Is this study eligible for WWC review as a regression discontinuity design? And I'll pause here for 1 minute to allow you to submit your answers. Okay, it looks like many of you have submitted your answers, so let's see what you thought. Okay, so we see that 80% of you do believe that this study would be eligible for WWC review. So let's take a look at the answer. So yes, the results are in, and so this study would indeed be eligible for WWC review as a regression discontinuity design. So let's walk through the answer just for a second. So here in this example, the study would meet the first criterion, namely that the intervention assignments are based on a numerical forcing variable. The study would also meet the second criterion because the forcing variable is ordinal and does have at least 4 unique values on either side of the cutoff value. This study would also meet the third criterion because there are no other obvious confounding factors in the study that would be perfectly aligned with either the intervention or comparison condition. And then finally, it does appear, based on the information provided, that the authors had access to the true or actual forcing variable used for assignments to conditions. So in summary, this study would meet those 4 criteria and would be eligible for review as an RDD. So for those studies that are eligible for review as a regression discontinuity design, the WWC has 5 standards that are used to review evidence from RDDs. And these standards are used to ultimately determine whether a study meets WWC RDD standards without reservations, meets those standards with reservations, or does not meet those standards. For each of the 5 RDD standards, there are a series of criteria used to determine whether a study completely satisfies, partially satisfies, or does not satisfy that standard. In order for a study to be rated meets WWC RDD standards without reservations, the highest possible rating, that study must completely satisfy all 5 of the RDD standards. Now for this webinar, we'll be focusing solely on the RDD standard number 5, which is the standard that applies to fuzzy regression discontinuity designs. More in-depth consideration of the RDD standards 1 through 4 are covered in the WWC's in-person RDD reviewer certification training. But as you can see here, the standard number 5 must be completely or partially satisfied in order for a study to receive those highest possible ratings of meets RDD standards with or without reservations. So now to drill down further into the RDD standard number 5. This fuzzy RDD standard includes 8 criteria that are used for reviewing evidence from fuzzy RDDs. This table, which you see on your slide, can be found on page 71 of the WWC Standards Handbook version 4.0. And this table summarizes the decision rules that are used to determine whether a study completely or partially satisfies the standard number 5. You see here that in order for a study to completely or partially satisfy the fuzzy RDD standard, studies must satisfy the first 6 criteria. The last 2 criteria clarify what distinguishes between whether a study completely or partially satisfies the standard number 5. And so now what we'll do is walk through each of these 8 criteria in turn. Criterion A of the fuzzy RDD standard states that the intervention participation indicator must be a binary indicator for taking up at least a portion of the intervention, and that could, for instance, include a binary indicator for receiving any positive dosage of the intervention. But simply put, the WWC does not synthesize evidence about the impacts of intervention dosage as a continuous variable, so a study would not meet this criterion if it used a continuous dosage measure for participation. Next, criterion B of the fuzzy RDD standard states that the model used to estimate intervention effects must have exactly 1 participation indicator. The WWC does not currently have standards for evaluating fuzzy RDD studies that use more than 1 participation indicator in that estimated impact model. Next, criterion C of the fuzzy RDD standard states that the indicator variable, which indicates whether participants are above or below the cutoff value on the forcing variable, that indicator variable must be a binary indicator for the groups to which participants are assigned. And then criterion D specifies that the same covariates, one of which must be the forcing variable, that those same covariates must be included in both the analysis that estimates impacts on participation, as well as the analysis that estimates the impact on outcomes. So for those authors using two-stage least squares estimation, as we discussed previously in the webinar, this would mean that the same covariates must be used in both those first and second stage equations. Moving on to criterion E, this criterion of the fuzzy RDD standard states that there must be no clear violations of the exclusion restriction. As we discussed previously in the webinar, the exclusion restriction means that the only channel through which assignment to conditions can influence outcomes is by affecting take-up of the intervention. So in other words, assignment to conditions should not influence take-up status, meaning that the outcomes of always takers and never takers should not differ. Some examples of common violations of the exclusion restriction include, for instance, when intervention participation is defined inconsistently for the intervention and comparison conditions, or when the assignment to the intervention group changes the behavior of participants even if they do not take up the intervention. So now moving on to criterion F of the fuzzy RDD standard. This criterion states that the study should provide evidence that the forcing variable is a strong predictor of participation in the intervention. So in a regression of program participation on a treatment indicator and other covariates, the WWC would operationally define strong evidence of participation as having a minimum F statistic of 16 or a minimum T statistic value of 4. So for criterion G, this criterion states that the study must use a local regression or related non-parametric approach in which the fuzzy regression discontinuity design impacts are estimated within a justified bandwidth using one of 3 potential approaches. Now it's important to note here that the WWC defines a justified bandwidth selection procedure as one that's selected based on a systematic procedure described in a peer-reviewed journal or methodological article that describes the procedure but also demonstrates its effectiveness. So for example, cross-validation, plug-in, and robust CCT procedures would all be considered justified bandwidth selection procedures. So in the context of criterion G, a study must use one of 3 possible approaches. First, the justified bandwidth selection procedure can be used for the fuzzy RDD impact estimate, namely that impact ratio that we saw earlier with the case estimates. Or the second acceptable approach is when authors use separate justified bandwidths for the numerator and the denominator of the impact ratio. And then finally, the third acceptable approach for satisfying criterion G is when the authors use a justified bandwidth in the numerator only, as long as that justified bandwidth is less than or equal to the justified bandwidth for the denominator of the impact ratio. Now you may recall that in order for a fuzzy RDD to be eligible to receive the highest possible WWC rating, that study must meet criterion G. So for fuzzy RDDs that do not satisfy criterion G, they can instead satisfy criterion H and still be eligible to be rated meets WWC RDD standards with reservations. So for criterion H, the study can estimate the fuzzy RDD impact using one of 2 approaches, namely using a justified bandwidth in the numerator only, or estimating the denominator of the impact using a best fit functional form, which we define here as a functional form of the relationship between program receipt and the forcing variable, and that fit has been shown to be a better fit to the data than at least 2 other functional forms. And this best fit can be based on any measure of goodness of fit from the methodological literature, such as AIC, BIC, or adjusted R-squared fit statistics. So now that we've discussed each of the 8 criteria used to review evidence from fuzzy RDDs, we can take another look at this summary table as a reminder of how those 8 criteria are used to determine whether a study completely or partially satisfies this RDD standard number 5. And again, it's important to remember that for fuzzy RDDs that partially or completely satisfy the standard number 5, their highest possible WWC rating will be meets WWC RDD standards with or without reservations. But it's important to remember that the final WWC rating for a fuzzy RDD will also incorporate information relevant to the other 4 RDD standards, and those are the standards relating to the integrity of the forcing variable, sample attrition, continuity in the outcome forcing variable relationship, as well as bandwidth functional form specifications. So now that we walked through each of these 8 fuzzy RDD criteria and clarified how each of these criteria relate to the fuzzy RDD's final WWC study rating, for the remainder of the webinar, my colleague Dr. Lukowski will walk through an extended example demonstrating the application of these criteria.
Thank you, Dr. Tanner-Smith. Okay, so as Emily just said, we're going to move on to applying the WWC review criteria for fuzzy RDDs to a fictitious study example that's based on the 3rd grade retention policy that we discussed earlier. Okay, so a U.S. state requires schools to retain 3rd grade students who do not perform at a basic proficiency level on the state reading exam, so a pass-fail. However, some students who pass the reading exam may be eligible for an exemption and thus are not retained. Furthermore, teachers may also elect to retain students who pass the reading exam but are deemed in need of retention. Researchers used the fuzzy RDD to estimate the comply or average causal effect of 3rd grade retention on students' subsequent academic performance on standardized reading achievement tests. Students are assigned to the intervention condition, which is retained, and the comparison condition, promoted, based on a continuous numerical forcing variable, the state reading exam. The state reading exam ranges from 0 to 100 with a cutoff value of 50. And the researchers have access to state administrative records containing the actual state reading exam scores that were used to assign students to condition. The researchers provide no indication that this cutoff value was used to assign students to any other interventions or services. So, is this study eligible for WWC review as an RDD? Yes, it is. So this study meets all 4 criteria for being eligible for review. First, the intervention assignments are based on a numerical forcing variable, so in this case, reading test scores. Second, the forcing variable is ordinal, with at least 4 unique values each above and below the cutoff, so there are 100 possible values in this example with 50 on each side. Third, there are no confounding factors in the study that are perfectly aligned with either condition. And lastly, the forcing variable used to calculate impact is the actual forcing variable used to assignment to conditions. Okay, so the authors estimate the comply or average causal effects using a 2-stage least squares instrumental variables estimation. The first stage and second stage equation are as follows. The first stage estimates the probability of the student receiving the intervention, which is being retained in 3rd grade, noted as R. R is a function of a dummy indicator, C, for whether the student fell below the cutoff value on the forcing variable, which is 50 on the state reading exam, as we mentioned. F, which is the continuous measure of the forcing variable centered at the cutoff. So in this case, 50 becomes 0, 51 is 1, 49 is -1, etc. Then we have C times F, which allows the relationship between the forcing variable, reading score, and R, the probability of retention, to differ on each side of the cutoff. And we have Z, which is a vector of student demographic characteristics such as age, gender, race, and prior year reading achievement. We have E, which is the error term. In the second stage, we're estimating students' reading achievement in the 4th grade, the outcome of interest. In the second stage, you can see that the equation is the same as in that first stage equation, with the exception of that instead of C, a dummy indicator for whether the student fell below the cutoff value of the forcing variable, we instead have R, which is whether the student was retained in 4th grade. Other than that, we've got F, the continuous measure of the forcing variable. We have that interaction between F and C to allow for differential slopes on either side of the cutoff. And we have Z, the same vector of student characteristics, and we have an error term. So does this study meet criterion A? Is there a binary participation indicator for taking up some portion of the intervention? Yes, there is a binary indicator for participation in the intervention. R, being retained, is just a yes or no. Here, there are no degrees of retention or dosage specified. Does the study meet criterion B? Does the model include only one participation indicator? Yes, there is only one participation indicator here, which is R. And does this study meet criterion C? Is the participation indicator binary? Yes, R is binary. It is a yes or no in terms of being retained or not. Now we're going to look at whether the study meets criterion D. Are the same covariates used in estimates of impact on participation and impact on outcomes? And again, the answer is yes. The same covariates are used to estimate the impact on participation in the first stage as are used to estimate the impact on outcomes in the second stage. So we have that same Z vector of demographic characteristics. So the authors explicitly state in the study that grade retention is defined consistently for the intervention and comparison groups. However, they also state that many parents of retained students reported seeking supplementary reading tutoring and instruction after being notified of their students' failing grade on the reading exam. Does this study meet criterion E? Are there any violations of the exclusion restriction? So yes, this study fails to meet criterion E. This is a violation of the exclusion restriction. Specifically, assignment to the intervention group changes behavior of the participants even if they do not take up the intervention. The authors estimate the two-stage least squares model using a bandwidth of 16. That's 8 test score points on either side of the cutoff value of 50. This bandwidth was selected using an approved optimal bandwidth algorithm, which identified an optimal bandwidth of 16 for the impact on participation and 24 for the impact on the outcomes. The authors reported that the t-statistic for the instrument was 3.87. Is there evidence that the forcing variable is a strong predictor of participation? Given this information, the study fails to meet criterion F. The forcing variable is not considered a strong predictor of participation, which is defined in the standards as a minimum t-statistic of 4. Does the study meet criterion G? Are impacts estimated with a justified bandwidth? Yes, they are. The study does meet criterion G. The impacts are estimated with a justified bandwidth. The authors used a bandwidth of 16, which is the optimal bandwidth for participation, the numerator. The bandwidth is smaller than the justified bandwidth for the denominator and thus satisfies criterion G. So does the study meet criterion H? Is the justified bandwidth for the numerator only or the denominator estimated using a best fit functional form? And this is not applicable because the study met criterion G. Great, so let's take a moment and review and determine the highest possible rating for this study. So if we look at the criteria that a fuzzy RDD must meet to completely or partially satisfy Standard 5, we see that unfortunately the study does not satisfy WWC RDD standards, either completely or partially for a fuzzy RDD. The study fails to satisfy criteria E and F, which it must satisfy for either condition. So the highest possible rating is that this study does not meet WWC RDD standards. I'm going to turn it over now to Dr. Polanin for a summary of what we did today.
Thanks, Christina, and thank you both for sharing that helpful information and expanding our understanding of the WWC standards as they apply to fuzzy RDDs. So our participants submitted questions during the registration process and throughout the webinar today, and we're going to spend a few minutes and turn to those now. And the first question today is for Emily, and it is, what resources does the WWC offer to evaluate fuzzy RDDs?
Yeah, this is a great question. So as we've discussed in today's webinar, the WWC's main resource regarding evaluating and reviewing evidence from fuzzy RDDs is going to be in Section 3 of the WWC Standards Handbook version 4.0. And so that's covered on pages 68 through 71 of the Standards Handbook. I'll also note that the WWC also has a reporting guide for study authors on regression discontinuity designs. And so that reporting guide provides guidance to study authors on the types of information they should be reporting in their own RDD studies, whether those be sharp or fuzzy RDDs, and again, providing those recommendations to ensure that authors can meet the highest possible WWC ratings. I think what has also been mentioned in the chat box today is that after this webinar, the materials from this webinar will also be posted on the WWC website, and so our hope is that today's webinar and responses to these questions and answers will provide an additional resource for participants.
Great, thanks, Emily. Next question for you, Christina. Are there future updates planned for the WWC's fuzzy RDD standards?
Thanks, Josh. So the upcoming release for version 4.1 of the WWC Standards and Procedures Handbook does provide additional guidance for reviewers on methods for estimating impact estimates from RDDs, whether those be sharp or fuzzy. Otherwise, there's no immediate planned updates for the WWC fuzzy RDD standards.
Great. Okay, the next question. The WWC Standards Handbook indicates that all RDDs must completely satisfy the fuzzy RDD standard to receive a rating of meets WWC standards without reservations. Is that true for sharp RDD studies? And do the fuzzy RDD criteria still apply in that case? And Emily, let's have you answer this one.
Yeah, so this is a great question because I do think that the language in the handbook could be confusing to some readers on this point. So as we discussed in today's webinar, the fuzzy RDD standard, or namely the RDD standard number 5 that we walked through in detail, that fuzzy RDD standard is waived for sharp RDDs, and it's also waived for fuzzy RDDs that use a reduced form model to estimate ITT impacts. So to put it in other words, sharp RDD studies do not need to completely satisfy this fuzzy RDD standard in order to receive that highest possible rating of meets WWC RDD standards without reservations. So as we talked about on today's webinar, the fuzzy RDD criteria, those 8 criteria, they're not applicable to sharp RDD studies. So sharp RDD studies do not need to completely satisfy the fuzzy RDD standard in order to receive that highest possible WWC disposition.
Thank you, Emily. And time for one more question, this time back to you, Christina. Do fuzzy RDDs have different attrition requirements compared to those of sharp RDDs to meet WWC standards? And for example, do fuzzy RDDs have more or less strict attrition boundaries for the non-compliers?
Thanks, Josh. This is a great question. No, fuzzy RDDs do not have more or less strict attrition boundaries than sharp RDDs. The WWC attrition boundaries are the same for both sharp and fuzzy RDDs. As discussed in the webinar, however, for all RDDs, whether they be sharp or fuzzy, it's important to remember that the samples used to calculate attrition must include all subjects who were eligible to be assigned to the intervention or comparison group using the forcing variable, and not only a subset of those subjects known to the researcher. So attrition cannot be assessed unless the subjects who were eligible to be assigned to conditions are known, and for all of these subjects, their assigned condition must be known. But again, the WWC does not have different attrition requirements for fuzzy RDD or sharp RDDs. These are for all RDDs.
Fantastic. Thanks, Christina, and thanks to all of you for those great questions. So this concludes our time for the Fuzzy RDD webinar. I'd like to thank our presenters once again, Emily and Christina, for a great presentation, as well as our participants for joining us today as we deepened our knowledge of fuzzy RDDs. Just as a reminder, the WWC SWAT team engages in webinars throughout the year to highlight important aspects of the WWC standards and procedures. Our planned webinars vary in topic, however, all have the goal of deepening our WWC knowledge. To learn more about webinars offered by the WWC and IES, be sure to sign up to receive notices through the IES listserv. The link in the chat box will take you to that listserv sign up. We will be posting an archive of the webinar along with the Q&A, including responses to questions we weren't able to cover today. And with that, I'd like to thank you all again for joining us, and have a great rest of your day.